Okay, today we're going to do two-digit counting number problems. We're going to be called that because every one of them is going to say the sum of the digits of a two-digit counting number is. I'm calling them those. What you need to establish is the structure of the number is going to be some digit and some digit to create a two-digit number. For example, if the tens digit is 8 and the units digit is 7, you have the number 87, right? So you're trying to find out the tens digit and units digit individually when you do this. And when they talk about the digits, if this says the sum of the digits of a two-digit counting number is 13, the tens digit added to the units digit makes 13. So you're just using the digits themselves as values. So something between 0 and 9 added to something between 0 and 9 makes 13. All right. When they start talking about the number itself, it says when the digits are reversed, they do that a lot, they reverse the digits a lot in these problems. The new number is 18 greater than the original number. Okay? The original number is going to be this. Okay, if you go back to maybe 3rd or 4th grade, I think, when you wrote numbers in expanded form, right? So if you have the number 87, that's 8 times 10 plus 7 times 1. We call the expanded form of a number, right? The tens digit is being multiplied by 10. The units digit is being multiplied by 1. That's all we're doing here. The tens digit we don't know yet is being multiplied by 10. The units digit we don't know yet is being multiplied by 1. If you reverse the digits, now u is in the tens place and t is in the units place, so that's the reversed number. Units in the tens place, t in the units place, so it's 10u minus t. So the new number, 10u plus t, is 18 greater than the original number 10t plus u. So they do that quite often, reversing digits and saying that one's bigger than the other. All right, so let's take a look at example 1. The sum of the digits in a two-digit counting number is 11. So again, as soon as you see two-digit counting number, as soon as you see those words, t is equal to tens digit, and u is equal to units digit, just to establish variables for the problem. And again, the words, the sum of the digits is 11. That just means we add the two digits up that we know. The tens digit t plus the units digit u is equal to the sum, which is 11. All right. Second statement, if the digits are reversed, okay, so when it says the new number, that is 10u plus t. Because again, we've already established with our naming of our variables here, it's in the order tu, so if we reverse the digits now it's ut. Units digits in the tens place, tens digits in the units place, so 10u plus t is the new number. We always ignore greater than, less than statements, right? So is 27 greater than? That's just an equal sign for right now, right? And then the original number. The original number is the original position of tens digit, units digit. So there's the original 10t plus u is the original number. All right? Now, if we focus on the 27 greater than now, it happens after the word is, so this is bigger than this by 27, so plus 27 goes on this side too. Fix that. So the top equation is ready to go. The bottom equation is all messed up. All right, so what I'm going to do is I'm going to move the 10t to the left. I'm going to move the u to the left. I'm going to subtract, or add, in this case subtract in both cases. So 10u minus u makes 9u, t minus 10t makes minus 9t, and equals 27. And like usual when I'm trying to do equation stuff, if everything divides by the same number, it's worth doing. So everything divides by 9, so u minus t is equal to 3. So this equation, after all the simplification possible, became u minus t equals 3. The top equation is t plus u. I'm going to rewrite it as u plus t though, equals 11. Just rearrange the order of those because that way the u's and the t's line up. And just like that, I've got myself a pretty simple system of equations here. The t's are already set to cancel. So u plus u is 2u, minus t plus t cancels. 11 plus 3 is 14. If 2u is equal to 14, that means u equals 7. Once we know what u equals, I go back to one of the equations. I'm going to go here. That says u plus t is equal to 11. U, which is 7, plus t, which we don't know yet, is equal to 11. That makes t is equal to 4. The question that they're asking us to answer here is, what was the original number? What's the structure of the original number? Tu, right? So the original number TU is going to be 47. Alright, keep in mind we're finding digits every time here, so the answer should be between 0 and 9, no fractions. If you get a negative digit or like a digit 17 or something weird like that, you're not going to be right. So when you get to this point, if it says U equals something between 0 and 9, chances are you got the right answer. If it says U equals 1.72, you did something wrong. U equals -5, you did something wrong. So just keep that in mind as you're doing the problems.